All right, this is for IM1 study guide for the spring final 2020. This is chapter 8 and chapter 9. All right, we're going to do problem number 1. And in problem number 1, we need to find out what the initial amount A is and the growth factor B is. We need the equation y equals A times B to the x. This is your initial amount, and this is your growth. So in this equation, this is your A, your initial amount, and this is your B, your growth. So A is 4, and B is the one with the exponent of x, so the B is 6. All right, the same thing applies for number 2. We have the same equation, y equals AB to the x. A is 125, and B is 1.056. Number 3, Ms. Swenson has noticed her students' grades have been increasing. Over the last few years, 2016, the class average was 75. Since then, the grades have increased by 1.2% each year. Which exponential equation could represent the growth in years? Remember, it's 1 plus the rate because we're increasing. So it has to be this one because the equation is y equals A, 1 plus your R, which is your rate, to the x. So that would be this one here. Your starting value is 75, and you're growing by 1.2%. 1.2% is changed. So here's the decimal right here, and it's changed 2 to the left. So 0.012. I'm going to go ahead and erase that little mark right here. There you go. All right, so that's why it's 1.012. All right, that's the answer for 1, 2, and 3. All right, this is the answer key. All right, let's go ahead and move down to number 4 now. All right, number 4, Savannah's parents started a savings account with $14,000 when she started high school. The account earned 6% simple interest each year. Which equation could this represent? So 14,000 is the starting value, and it's gaining interest, and 6% is 2.06. So that would be this one. It's gaining because it's earning interest. When it says earn, so that means it's gaining interest, not losing. Number 5, Savannah's parents started the savings account with $14,000 when she started high school. The account earned 6% simple interest. How much money is in the account after 4 years? So we're going to go ahead and use the calculator for that. I recommend using a Google calculator. So go to Google calculator if you don't have your own at home. And you're going to make sure you know what you're doing. So let's look at the equation. It's 14,000, 1.06, 4 years. All right, so we're going to go back to the calculator. 14,000, parenthesis, 1.06, parenthesis, and this is going to be, this is the exponent button. So raised to the 4 years. All right, the answer is 1767, and this rounds to 675, 17675. All right, so let's go ahead and go back. 17675, that would be C. Don't forget to put what you typed in the calculator. That's what we typed in, and this is what we got. All right, so that's the answer for 4 or 5. All right, let's do number 6. All right, number 6, we have Sarah bought an item that increases in value. She bought the item for $450. It increases by 7% each year. How much will it be after 20 years? So the starting value was $450, and it increased by 7%. 0.07% if you divide by 100, or if you just move it twice, it gives you 0.07. And it's 20 years. So we're going to put that in the calculator. So let's go ahead and go to Google again and go to their calculator. 450, so let's clear it. 450, parenthesis, 1.07, close parenthesis. Here's the exponent button, xy, so x to the what power? 20th power. And that gives you 1741. So let's go back, 1741. That would be B. All right, number 7. A bacteria colony of 200 grows by 25%. Remember, 25%, you need to move twice to the left. 0.25. How many bacteria will there be after 7 days? So we have 200 times 1.25. And 7 is the number of days. So let's put that in the calculator. And let's go ahead and do that. 200, so let's clear this. 200, parenthesis, 1.25, parenthesis, raised to the 7th power. It gives you 953.67, so about 954. All right, 954. Let's remember that, 954. So it's this one. All right, so that's the answer for 6 and 7. 6 was B, 7 was A. All right, let's move on to number 8. State whether the equation represents exponential growth, decay, or neither. If it's greater than 1, the multiplier, then it's growth, but this one's less than 1 and greater than 0. So if it's between, if x, or the value of b, if b is between 0 and 1, so less than 1, like this one, 0.8, then it would be called decay. If it's greater than 1, it's growth. And 0.8 is in between, so it is decay. It's less than 1, greater than 0. Mr. Williams bought a used car in 2015 for $13,000. Unfortunately, the value of the car depreciates, so decreases, at a rate of 6.5% each year. Which of the following will work? So it would be this one because of the minus sign, because it's losing value. Number 10. Identify the initial amount A and the growth factor B in the exponential function. So we have A is 450 and B is 0.075. 11, Bob bought a car, $18,000. The car loses value by 9%. What equation could represent this? So losing value, not plus, it's gaining, so minus. So it's this one. All right, so 8 is B, 9 is B, 10 is 450 and 0.075, and 11 is A. All right, let's erase this and move on to 12. 12, 13, and 14. 12, Bob bought a car for $18,000. The car loses value by 9% each year. How much money is worth it after 4 years? So 18,000. Make sure you get the right number of zeros. 1 minus 0.09, because 9% is 0.09 raised to the 4th power. So let's put that in the calculator. So let's go to the calculator. So erase this. 18,000, parenthesis, 1 minus 0.09, parenthesis, to the, this is the exponent, 4th power. 1, 2, 3, 4, 3. 1, 2, 3, 4, 3. All right, so let's look at the answer. 1, 2, 3, 4, 3. 1, 2, 3, 4, 3. Another B answer. All right, number 13. John bought a computer which loses its value as it ages. He bought it for $850. Decreases by 6%, 1 minus 0.06. How much will it be worth after 20 years? 20 is your exponent. So let's put that in the calculator. So let's go and do that. So 850. All right, so we're going to type in 850 parenthesis 1 minus 0.06 to the 20th power. 246.59, so about 247. 247. So let's go back. 247. All right, not that one. Let's go to this one right here. 247. All right, so let's go to 14. Bacteria, it started with 2,000. So let's see here. Started with 2,000. It dies off, which means decreases by 25% each day. How much bacteria after 5 days? 2,000. 1 minus 0.25 raised to the 5 days. All right, let's put that in the calculator. All right, let's see here. Let's get the right thing here. 2,000. Let's clear that. 2,000. 2, 0, 0, 0. Parenthesis. 1 minus 0.25 raised to the 5 years. 474.6. So about 475 is what it rounds to. All right, let's pick the right answer. 475 is B. All right, that's it for part one. Part one is exponential growth and exponential decay. So that's it for that. Let's go to part two in just a minute.